So now we're moving on to Chapter 1, Section 5, Solving Equations with Variables on Both Sides. So we've been solving equations for the past few days, but all the variables have just been on one side of the equation, and that's how we've been solving the equations. So today we'll have a variable on both sides of the equal sign. To solve an equation with variables on both sides, the very first thing we want to do is simplify one or both sides of the equation if necessary. So I want to look at both sides of my equation, see if I have any like terms that I can combine and simplify. If I don't have any like terms or I can't simplify either side, then I don't have to worry about that first step. We then want to use our inverse operations to collect the variable terms on one side of the equation. So that's the next thing we want to do. We want to get all our variables on the same side of the equation together. Then we want to collect the constant terms on the other side away from the variable. So we want to get our variables on one side of the equation, our constant terms on the other side of the equation from the variable. Constants are just our numbers without variables. And then the last thing, we just isolate the variable, solve for the variable to solve our equations. So let's jump into some examples. So the first thing I want to do is I want to see if there's any simplifying I can do on the left hand or right hand side. Looking at the left hand side, there's no like terms to combine, anything like that. I cannot simplify anything on that left hand side. I cannot simplify anything on the right hand side either. So I just move on to my next step, which is move my variables to one side of the equation. So I'm going to add 4x to both sides. Once again, we have to use our inverse operations. So I get 10 equals negative 5x. So I have my variables on one side, my constants on the other. Now I can just solve my equation for x. So I'm going to divide both sides by negative 5. I get x equals negative 2. So there's my solution for number 1, but it wants me to check my solution. If it asks you to check your solution, you must check your solution. So 10 minus 4 times negative 2 equals negative 9 times negative 2. Negative 4 times negative 2 is positive 8. Negative 9 times negative 2 is positive 18. 10 plus 8 gives me 18. 18 equals 18 is a true statement. 18 equals 18 is a true statement, so I can be confident that my answer is x equals negative 2. Now let's look at number 2. Negative 2x equals 3x plus 10. Once again, in this case, I don't have any simplifying I can do on either side, so I'm just going to move my variables to one side of the equation. So I'm going to subtract 3x using my inverse operations from both sides. I get negative 5x equals 10. Now I can solve for x by dividing by negative 5. I get x equals negative 2. Once again, need to check my solution. So negative 2 times negative 2 equals 3 times negative 2 plus 10. Negative 2 times negative 2 is 4. 3 times negative 2 is negative 6. And then negative 6 plus 10 gives me 4. 4 equals 4. It's a true statement, so I know my answer checks out. Hopefully that makes sense. It's not adding too much to what we've done in the past. It's just adding a few extra steps at the beginning to get the variable on one side and the constant on the other. So now let's look at solving an equation with grouping symbols. This just, like I said, just adds one more step. If I have grouping symbols, I need to go ahead and distribute if I'm able to. So I'm going to distribute my 3 all the way through, my 1/4 all the way through. 3 times 3x is 9x. 3 times negative 4 is negative 12. 1/4 times 32x is 8x. 1/4 times 56 gives me 14. So I've now distributed. Now I want to get my variables on the same side of the equation. So I'm going to subtract 8x from both sides. I get x minus 12 equals 14. And now I want to get my constants on the opposite side of the equation for my variable. So I'm going to add 12 to both sides. And I'm going to get x equals 26. And there would be my solution for number 1. The directions here don't tell us to check our solution, so you don't have to check your solution here unless you absolutely want to. Now let's look at number 2. Once again, I need to distribute on both sides of my equation. Negative 3/4 times 8n gives me negative 6n. Negative 3/4 times 12 gives me negative 9. 3 times n is 3n. 3 times negative 3 is negative 9. I'm going to get my variables on one side of the equation by subtracting 3n. Negative 9n minus 9 equals negative 9. Get my constants on the opposite side of the equation. So I get negative 9n equals 0. And now I can solve for my variable by dividing both sides by negative 9. I get n equals 0. So if you have grouping symbols, just go ahead and distribute to get rid of them, and then follow our steps like normal. Now sometimes equations do not always have just one solution, like we just saw in all our previous examples. An equation that is true for all values of the variable is what we call an identity, and it has infinitely many solutions. An equation that is not true for any value of the variable has no solution. So it can have no solution, it can have one solution, or it could have infinitely many solutions. So let's look at some examples like that. Now these problems look very similar to problems that we've just been doing on the previous slides. So let's treat them like we would those. We're trying to get the variable by itself. So the first thing I need to do on A is distribute. Get 15x plus 6 equals 15x. I want to move my variables all to the same side of the equation. So I'm going to subtract 15x from both sides. I'm left with 6 on the left hand side. But my x cancels out on the right hand side as well. 15 minus 15x would give me 0x. Anything times 0 is 0, so I don't even need that x there. So I'm left with 6 equals 0. My variable just completely went away. It canceled itself completely out. 6 equals 0 is not a true statement. It's a false statement. So if your variables cancel each other completely out, and you're left with a false statement like we are right here, then my answer is no solution. So letter A is no solution. You can write out no solution, or you can use our symbol for no solution, which is a circle with a slash through it. What this means is there is no number that will make this equation true if I plug it in. No matter what number you pick to try to plug into the equation, it's not going to be true. It has no solution whatsoever. So once again, if your variables cancel each other completely out, you're left with a false statement. Your answer is no solution. Let's look at letter B. We need to distribute. It gives me negative 8y minus 2 equals negative 8y minus 2. Get my variables on the same side of the equation. But once again, my variables cancel each other completely out. I'm then left with the statement negative 2 equals negative 2. Unlike letter A, this is a true statement. Negative 2 equals negative 2 all day long. So if your variables cancel each other completely out and you're left with a true statement, your answer is infinitely many solutions. So this would be my answer for letter B. We don't have a symbol for infinitely many solutions. It's not going to kill you to write out 3 words, so go ahead and write it out. Don't put IMS. Go ahead and write out infinitely many solutions. Also, don't write the infinity symbol because my answer is not infinity. I just have an infinite number of solutions. So go ahead and write out infinitely many solutions. So recap over these two. If your variables cancel each other completely out, you're left with a false statement. You get no solution. Your variables cancel each other completely out, you're left with a true statement. Your answer is infinitely many solutions. So this last slide is just some steps for solving linear equations. Depending on the equation, you may not need to use some of the steps. So step 1, use the distributive property to remove any grouping symbols. You may or may not use that step. If you have grouping symbols, you're going to use it. If you don't have grouping symbols, you're not going to use it. Step 2, simplify the expression on each side of the equation. Once again, only if you can. Sometimes you're not going to be able to simplify on either side. Step 3, collect the variable terms on one side of the equation. So collect your variables to one side first. And then collect your constant terms on the other side of the equation, away from your variable. Get your variables on one side, your constants on the other. Step 4, solve your equation by isolating the variable. And then step 5, if it asks you to check your solution, you can check your solution. You need to check your solution. If it doesn't ask you to, then you don't need to worry about it unless you absolutely want to. But if it does tell you to, you do need to do it. So here is our homework. Page 35, numbers 4 through 26 evens. Some of these will go pretty quick. Just make sure you're reading the directions and make sure you're checking Canvas because this will be due on Canvas, looking for that assignment to be able to turn it in. If y'all have any questions, please let me know.